Hello, all of you. So let's start the discussion of divisibility rule. As I have started the number system topic, divisibility rule is one of the discussion. So the basic understanding of divisibility rule is like how to check a number is divisible by two, how to check a number is divisible by three, those concepts. Okay. So let me start as the simple thing: how to check a number is divisible by two. So all of you have the idea, like if I say how to check a number divisible by two, then we check only the last digit. Say if a number is a, b, and last digit is six. If the last digit is divisible by two, the number is divisible by two. Fine enough. Or you can say the even number. And how to check the even number? The last digit is even. Now the questions come: what is the divisibility rule of four? What do you do for the divisibility of 4? We check the last two digits. So instead of one digit, we are going to check the last two digits. So the last two digits are 2, AB and 28. AB could be anything. If the last two digit 28 is divisible by 4, the entire number will be divisible by 4. It could be XYZ 60. Is 60 is divisible by 4? Yes. So the number will be divisible by 4. We're going to check the last two digit. Similarly, for 8, we are going to check the last three digits. And for 16, we are going to check the last four digits. So how this works? 2 to the power 1 is 2, single digit. 2 to the power 2, 4, 2 digit. 2 to the power 3, 8. 2 to the power 3 is 8, 3 digit. 16 is 2 to the power 4, 4 digit, and so on. So if for 2 and its power, if the power is n, we check the last n digit on that case. And the same happens in case of 5. Because if I say, what is the divisibility rule of 5? What do you say? Any number that ends with 5 or 0. That means the same. I means the last digit is divisible by 5. Now, what is the divisibility of 25? I'm going to check the last two digit, like X, Y, Z, whatever you say. If the last two digits are 75, 75 is divisible by 25, so the entire number will be divisible. And 125, the last three digit, 625, last four digits. So same thing, 5 to the power 1, 25 is 5 to the power 2, 125 is 5 to the power 3, and so on. So for 2 and 5, whatever the power we have, we check last n digit. Okay. So next, let me discuss the divisibility rule for 3. Now, what is the divisibility of 3? I will now discuss the divisibility of the rule of 3 and 9 together, because they have the same rule. What rule? If a number is say A, B, C, to check the divisibility, we add A, we add B, and we add C. If the sum of the digit is divisible by 3 or 9, the number will be divisible by 3 or 9. So to understand the like why I have this kind of rule, what do you do? We can break this number ABC as 100 times A, I hope you know that, plus 10 times B plus C. Okay. So this can be written as 99A plus A, 100A. 10B I am writing at 9B plus B, 10B, and I already had C. Now whatever we have inside this is 99A and 9B. This part is already divisible by 3 and 9. Because it is 99, it is 9, no, it will already get cancelled by 3 and 9. So if this part is divisible and I want entire number to be divisible by 3 and 9, the counterpart, A plus B plus C, this should be divisible by 3 and 9. Then I can assume and they can ensure that the entire number is divisible by 3 and 9. And that is what the rule is. Now, here in case of 9, we must understand the digit sum concept. Now what is digit sum? If I have a number like 7777, whatever, this is a 4-digit number and it has the digit 7777. If I add the digit, this is called sum of digits, is equals to 7 plus 7 plus 7 plus 7. 7 4s are 28. This is called sum of the digit, but what I have written is different. Digit sum. Now what is digit sum? Whatever 28 you have got, the digits of 28, that is 2 plus 8, can further be added. I got 10. And again, the digits of 10 can further be added. 1 plus 0, 1. And now I cannot add further. So this is what called the digit sum. Digit sum, DS. So for any number, when you add for the first time, what happened? You got the sum of the digit. And then if you keep on adding, and you reach a single digit number, after that the addition is not possible. We call this is to be digit sum. Now the connection of digit sum with 9 is very, very unique. The digit sum connection with 9 is very, very unique. What is the cases? Like for any number which is a multiple of 9, say the number which are multiple of 9, what are the multiples of 9? 9, 18, 27, 36, whatever you say, 729. All the number have the digit sum as 9. They have the digit sum is equals to 9. Check it out. 1 plus 8 is 9, 2 plus 7 is 9, 3 plus 7 is 6 is 9. Even if 7 plus 2, 9 plus 9 is 18. 18 is 1 plus 8 is 9. Got it? And also about the cases which are not a multiple, of 9. What is the not a multiple of 9? Say I am talking about 31. Is 31 is multiple of 9? No, it's not a multiple of 9. So if 27 is a multiple of 9, this is when divided by 9 leaves the remainder 0. But 31 is not a multiple of 9, so it will not leave a remainder 0. What is the remainder it will leave? So 31 when divided by 9, you can normally divide check. 3s are 27, you know that. I am doing very basic things. What is the remainder? 4. The reason being, I can do it the other way around. 31 when divided by 9, the remainder is 4. That I could say that the digit sum, yes, 3 plus 1. You are right. 3 plus 1 is 4. So if I say 86 when divided by 9, what is the remainder? You know that 9 9s are 81. So 81 means the remainder is 5. How could I do it with the digit sum concept? That is 8 plus 6, 14. 1 plus 4, 5. And the remainder is 5. So the concept of digit sum and a multiple of 9, these are correlated. What is the concept? If the digit sum becomes 9, it's a multiple of 9. If the digit sum is k, then k is nothing but the remainder. Okay. Now, after 2 done, 3 done, 4 done, 5 I have done with multiple of 3 and 6. Divisibility rule, I mean 2 is done, 3 is done, 4 is done, 5 is done. So if you look at this way, no, divisibility rules are not an issue. It is easier to understand. Okay. Then I left with what? 6. What is the divisibility rule of 6? Rule of 6. The rule of 6 would be, if an even divisible by 2 and 3, I can say if even number divisible by 3, even number means divisible by 2 and then by 3, it is divisible by 6. Done. Now let me check the divisibility rule of 11. 10 I am not doing, 8 is done. Now the divisibility rule of 11 is, suppose a number is A, B, C, D. What you do, you mark them like 1, 2, 3, 4, and you add the odd place digits, and you add the even place digits. So you have one odd place, we have B and D, so we add, and even place I have A and C, add. If the difference is 0 or divisible by 11, like 11, 22, 33, then this is the rule. Or someone can say, I'll do the odd places and the even places. Like, or can say alternate place. I'll take this is plus, this is minus, this is plus, this is minus. Same rule. B and D getting added and A and C getting subtracted. So alternate plus minus is also a rule. Now someone may ask, like, why we don't have a rule for divisibility of 7. Yes, rule of 7 is also there. Rule of 13, 19, 17, you can create your own rules, but those are not required. So if I say, what is the divisibility of 7? Say A, B, C, D is a number. E, F is a number, say. So the rule of 7 says, you multiply the last digit by 1, multiply the last digit by 1, then second digit by 3, then by 2, then minus 1, minus 3, minus 2. So to check the divisibility of 7, the multipliers are 1, 3, 2, minus 1, minus 3, minus 2, again 1, 3, 2, and so on, so on, so on. You multiply and check the sum, it is divisible by 7 or not. Let me take a number to make these things clear. Say 4858, I took a number, and I have to check whether this is divisible by 7 or not. So the concept says, last multiply by 1, second next multiply by 3, next multiply by 2. Exhausted, so minus 1. So we have 1, 3, 2, you remember 1, 3, 2 only, and then you have repetition 1, 3, 2, positive, negative. Okay. So if you look at, this become minus 4, this becomes 16 plus, this become 15, this become 8. So the summation is 31 plus 35. Is 35 is divisible by 7, then the entire number is divisible by 7. Now this is not the only rule available for 7. There are other rules available for 7. There are other rules for 7. Okay. You can check another rule. Say 4858 is the number. The rule says, double the last digit and subtract from the remaining digit. And subtract. What is the last digit? 8. Double it. 16. So 485 minus 16. 469. Again the last digit is 9. Double it. 18. And what are the remaining digits? 46. So 46 minus 18. 28. Now is 28 is divisible by 7? Yes. So the entire number is divisible by 7. You can go with either method. Okay. Now someone may ask how we have a rule for this 132, 132. I'll be discussing the concept of 132, 132 over here. Like why you have the rule of 7 this way. And to explain this, let me take a number A, B, C, D. I'll explain this as 1000 times A plus 100 times B plus 10 times C plus D. I expanded this. Now I'll search for a number which is close to 1000 and divisible by 7. You can search 1001 is such a number. So instead of 1000A, I wrote 1001A. So I'll subtract A to balance it. I'll do the same. I'll search for a number which is close to 100 and divisible by 7, which is 98. Then I'll do it same for 10. I'll do 7C. Now it's time to adjust. I already had minus A. Just a minute. I already had minus A. Then I written 98B. So I'll add down 2B. Then plus 3C. Because I have 10C, I just have written 7C. So this is, and I already had D. Don't forget it. Now check what happened. This part, whatever we are doing, it is already divisible by 7, no problem, because all are multiples of 7. And what the counterpart I have? Is it not the same? Multiply D by 1, multiply C by 3, multiply B by 2, and this is multiplied by 1. And if you proceed further, you get the same pattern I have discussed. So that's how the rules came. So suppose you want to create a rule for 13, you can create your own rules by expanding this. Okay, so these are basic discussion of the divisibility rule. Watch for the questions discussion from this concept. Thank you.